the Hochschule Bremen is very well equipped, and this immediately works. Fantastic. So, Gregor, thank you for the introduction. I have been introduced so far. I'm the Managing Director of Schiffstechnik Buchloh. I will go through the agenda with you, have some general words, and my main job to do is doing some marketing. So Max is here as the technical expert, and maybe Max can introduce himself as well.
Yeah.
One thing before that, so my colleagues are filming this session. We are wearing some microphones. So if you don't want to end up somewhere online, just look forward, you won't be seen. So and
you won't be heard.
Yeah. So if there is anybody who is not willing to end up somewhere online, there is a safe space to not be seen or something, so that would be fine.
Yeah, thank you. My name is Max Kolkmann. Thank you, Gregor, for the introduction. I studied naval architecture in Bremen as well, and I work for Schiffstechnik Buchloh as a project engineer, as Gregor also introduced. And I will tell you a little bit about the actual topic of today, which is the adaptation of modern energy resources to ships and the problems coming with it, but also the possibilities coming with it and how it affects our work, basically.
Good. So going through the today's evening's agenda, I will shortly describe what our company does, where we come from, what we have been doing in the past. I have some slides about our internal structure, and I brought some references, and Max will take you on a journey through the actual development of naval architecture and the development of our role as experts in ship design and energy systems on board. So what do? We are located in the area around Cologne and Bonn on the Rhine River, and we are coming out of the field of inland waterway navigation, and we are our portfolio consists out of concept design, basic design, and detail design, pretty much like every naval architect's office in the industry does. But we tend to take it a step further. So every project we are taking on is important to us that we are capable of detail designing those vessels. So we are capable to deep dive into our tasks. So this is why we have chosen our slogan you have seen in the beginning. We are also doing the manufacturing preparation, so down till workshop drawings, cutting files, profile lists for the steel, and also for the spools for pipelines and so on. So this is what we are capable of doing. We do not do that for every project, but this is mostly what we're doing. We also execute renderings for our clients, which are becoming more and more important, especially for investment decisions or political decisions. We have capabilities in the field of CFD and FEM analysis. We have our colleague back there, Hendrik, where is he? Who's doing the 3D scanning. With a few of our colleagues, but Hendrik is the, let's say, head of 3D scanning. Oh, that's bad for our next annual discussion. So then we also do special constructions, which are easier to explain with some slides I might have. And we are also doing building supervision. So mostly on the ship owner side, it's building supervision. And if something goes wrong, we do consulting and expert evidence. But let's say this is something we are more or less developing out of the field of expert evidence, as the market for new builds and conversions is quite big. About our history, so where do we come from? My father was a part of a bigger naval architect's office based in Unkel, which everybody knows. It's a really famous city on the Rhine. And our former President, wie heißt er noch? Willy Brandt used to live there, so it's really famous. And in the house next door was the actual naval architect's office. So he dropped out of this position, and then he founded his own company with one employee. And after 10 years, he had already been tackling on approximately 500 projects with a staff of 5. In 2017, pretty much directly after my studies, I joined the company. I used to do a double degree bachelor education at Meyer Werft shipyards, and pretty much after Gregor signed my thesis, I went into the family company because my father became sick, and we always had the plan to work together, but 2 years later, sadly wise, he passed away. But in the meantime, we had the time to restructure the company by itself. So we had the opportunity to implement a new PLM system. We had to rearrange the staff, so I couldn't jump into a position where you need 35 years of experience. So we restructured the staff. And in 2021, which was, let's say, the post-COVID year, we were able to still maintain well in business. We had seen a lot of competitors going sideways, and now it's 11 of us, and we are forming, let's say, our first department. So we have experts in the field of machinery, we have experts in the field of FEM, in the area of outfitting, general arrangement plan, and so on. Most of them are here in the back row there because it's our Christmas party tonight, which we are looking forward. So we're gonna have a crazy night in Bremen, so we're looking forward to that. And then currently we are also working with agencies. So we have found the first agent in Greece, where we have a agency agreement with. We are currently trying to find an agent in Hong Kong, and we are in deep negotiations with them. About our structure, it looks very steep. It actually isn't. So we have the management, which consists out of Fabian and me. Fabian is the gentleman behind the camera. We have Barbara, who is doing the administrations. So keeping things together, planning parties like tonight, and sending us around the world for different jobs. And most important is our staff down here and our project management level. So those guys are getting stuff done. Not me, I'm just selling here. I'm a PowerPoint engineer now. So I'm not productive, not really anymore, sadly wise. Fabian and Max are taking on the projects as project managers, and we have our colleagues on the expert level doing the different fields of naval architecture in the different disciplines. I've brought some for the guys haven't seen us on the Schiffbauertreffen in the last years. I've brought some small references, and then I'll be done and hand it over to Max. So where we come from is the inland sector. So we have some very well-known clients who are from the event, or used to be like a day tour business. But now it's more event business, where we have the chance to develop a yacht-like event vessel for 1,000 passengers. So it's made for different functions, which you can separate. It's made for big company presentations, presentations along fairs in Cologne and in Düsseldorf. So those designs are quite outstanding, and a lot of cooperation with the ship owner, which we like a lot. This is something that might look familiar to a few master students that we have here. So a topic we've been working with is a class of ships that is being built at the moment, or the second one is being built at the moment. The first one is finished. So this is a push convoy powered on a hydrogen hybrid system. So the ship owner has the vision to, let's say, to be the first mover in matters of hydrogen as a fuel on ships, and he has a strategy in those vessels, and we have developed a strategy with him to decommission the diesel engines over the time and ramp up the hydrogen power inside. And the vessel is designed in a manner that we can throw out the diesel gensets and ramp up the hydrogen power inside. thinking about the discussions we have within the master group, so this one is equipped with 2 times 1,000 kilowatts electrical engines on the shafts, and it's a push combination out of 3 push barges, so 2 by 2, and the motor vessel. And something you will have seen in the media or in the neighbor town, which we do not like too much here, is the new class of harbor ferries for the haddock. We were allowed to deliver the basic and detail design. So the owner, the haddock, came up with a concept design which had been developed for the tender, and we were working on the shipyard side as the basic and detail designer. And yeah, there was a hell of fun. And now the third one was just in the inclining experiment last week. Monday, exactly. And the third one will be delivered within the next weeks. 2 are already in service, and the third one is coming. And this is pretty much it from my side.
Yeah, thank you very much. So this is already rolling here. So what I will deal with is basically the steps before the concept design phase. So today, life has changed a bit. Here we have the conventional side of how to design or how to concept design a ship, and that's what we learned in university. We have a customer who has a demand or an idea or a problem. In the end, he needs a ship, and he has a few boundary conditions: length, breadth, depth, power, speed, cost. Then we have the very well-known design spiral, and in the end we put a diesel engine in it. We have a smoking ship. It works fine, but this is not state-of-the-art anymore. So this all has become a lot more complex. So we have various energy sources which can be used. We have diesel, we have ammonia, we have methanol, we have electric batteries, we have hybrids. And what we developed is a kind of a filter system which comes before the actual concept stage. So the aim of this funny looking thing here is to get an idea what is suitable for which kind of ship before we even start designing it. So we save, in the end, we save time and we save effort because we don't have to design 10 different variants of a ship, but only the one which really works. We have a lot more boundary conditions than in the past. This is just a short list. We have political stuff, we have climate stuff, we have more regulations, we have more dependencies, we have funding, so it's really complex. So the idea is that still the customer has an idea, has a problem, still needs a ship. There are also very complex boundary conditions, and then we filter the different energy sources until we qualify what is suitable, and then we start into the design spiral. What makes it even more complex is that we don't really know what would happen in the future. So technology is evolving, and we still don't know how well batteries will perform in the future, how the regulations change for ammonia, and so on. So we have to keep in mind that our ship lasts for decades, and we don't know what is in 30 years. So the design is also affected by changes, and the sooner we think about the changes, the easier they are to do in the future. This is quite abstract, and I will try to explain it with 3 different projects we did. So, yeah, that's basically what I just said. The first example is a ferry. So this is a double-end ferry traveling over a river in Germany. Here we can see the old one. And the customer has an idea. He wants 200 passengers, and they have big problems with shallow water, especially in the summer. And there are the boundary conditions, so the crossing must not be longer than 3 minutes. And the old ferry already has very shallow draft, but the new one should have even less. So it's able to operate on more days in the year and make more revenue. Of course, they also want energy saving, sustainability. They don't want black smoke coming out of it, and they want it to be future-proof. So we took our filter system, and the first one is the operational filter. So the customer is in the countryside, basically, so there's not a lot of infrastructure around it. So there's no hydrogen supply pipeline or some harbor infrastructure or something like that. There's just green grass. So there's no opportunity to fill up hydrogen tanks on the ship. So if we wanted to use hydrogen, we would have to use exchangeable tanktainers. We put them here, these are 20-foot units. Just as an example on the ship, it doesn't really make sense because it takes so much deck space, it's not really suitable. So hydrogen is filtered out and not suitable for the project. The next one is the technology filter, and there the ammonia is filtered out. Here we can see this is an example of an ammonia system on an inland waterway passenger vessel. We have exclusion zones in the engine compartment. We have a blow-off mast. We have a dangerous area behind the ship, which is unlimited high and goes down to the waterline. So this is really a big system and it's really complex, and also this blow-off mast is not suitable on a double-end ferry. So on the technology side, this is filtered out, it's not suitable for the ship. Then we have the business filter, which is more or less the most important. The customer is not a private company, but it's kind of publicly owned. So they want to have very strictly calculable cost. So they want to know what will the ship cost by what will be the capex. So how expensive is it, and what will be the OPEX, so what will it cost to operate the ship in the future. And we don't know what methanol costs, and the client just doesn't want it because it's hard to estimate. So methanol is also out. So the three options left are diesel, hybrid, and battery electric. And with that, we went into the design spiral and did the actual concept design. You can see two Voith-Schneider propellers in there on a symmetrical double-end ferry. Here's a big battery compartment, and here are two diesel gensets with cooling and all the systems and so on. This is designed in a way that you can exchange the diesel gensets by additional batteries in the future very easily. We have these switchboards down here, and I think up there, which is a DC link, so it's an electrical linkage, and you can pretty easily put more energy sources on the system in the future. Yeah, and this is how we designed, and in the end we ended up with hybrid, but in the future it could end up being fully electric. This is the design, it's a lovely rendering done by our colleague who can't be here today, unfortunately. So, then we have another ship, which is kind of similar, but still very different. This is also a ferry, also operating on a narrow river, but more on this in the city area. It must not carry cars, but only pedestrians and bicycles. And it should be prepared to operate autonomously in the future. The customer also wants zero emission. This is a hard boundary condition, so it's not a can be, it's a must be. He wants it to look modern, so here we already see the finished design. It must have low draft, and the main dimensions must be pretty small, but still fit a lot of bicycles. And again, we have our filters here. First of all, the operational filter, or also we can call it the organizational filter. So the customer says he wants zero emission on site. So everything having to do with combustion is not possible, is immediately filtered out, which makes the process a bit more straight line. We also have here, again, the operational area is just a river crossing, and here already a rendering of the finished ship. In the technology side of view, both electric batteries and hydrogen are possible. But again, we don't have a hydrogen fuel station there. We don't have a lot of infrastructure. So we had to also use these tanktainers for hydrogen again, which would extend the major dimensions of the ship quite a bit. So we decided to not use them, but go fully electric from the beginning on. On site, we have 300 kilowatts of electrical power to charge the ship, which is quite a lot. And we can calculate what electricity costs in 2 years and also in 10 years. This is quite known and easy to expect. Also, hydrogen systems are pretty expensive, and they are also expensive to maintain. Fuel cells lose power over time, and this makes, together with the maintenance, makes it quite expensive. So we decided to go electric. We have more space on deck, and we have more passengers, which is more money in the end. Here we can see the actual design. I think the most important bit is the space below deck. We have 2 different battery compartments for damage stability. So if one is flooded, then the other one still works, and the same is suitable for fire. In the aft ship, we have 2 conventional shaft lines with electric motors on it, and the entire hull is optimized for maximum efficiency. So we don't need a lot of power, which is very important for battery-propelled ships. Yeah. So this is the second ferry. In the end, it's actually fully electric. Again, lovely rendering, again from the same colleague. Yeah. And the last one is very different to the others. So this is the old ship. The customer wants a new one. This is the old one. It's tiny. It's about 8 meters long. And it's operating in the Wadden Sea, in the North Sea in Germany. And it's used mainly for towing small barges to building sites for coast protection. So they have material like these small wood branches they use for coast protection, and these need to be towed to the actual site on the coast from the harbor. So very important, as it is a very small tugboat basically, and it needs a lot of bollard pull. The old one is relatively powerful, but not really. So they want more. But on the Wadden Sea, you are very constrained in draft, and zero emission is a can be here. So the customer wants it, but we check during our phases, which I come to now, if that's suitable. In addition, the new boat must not be bigger than the old one, because they have a very tiny kind of lock in the harbor where they have to enter, and so the main dimensions are very constrained. And again, our filters. We have the operational filter, and we have the Wadden Sea area. Here we have a small image of it. This is not really with a scale, but the ship travels quite a long distance, and the operation works in a way that they are not in the harbor for a few consecutive days. So if we think about battery electric, we don't have the possibility to charge overnight, not every time, which would make the battery compartment pretty big. And we are in the very well protected national reserve. So the Wadden Sea is very protected. You are not allowed to do a lot of things there. And handling quite poisonous ammonia is not a well idea for this. And you saw this big blow of mass, so we immediately kicked the ammonia idea out.
Maybe some extension to that. It's also the owner is in Germany we would call it an Umweltamt. So they do not like to end up in the media killing seals and stuff like that. So this is why we went away from ammonia as well.
Yeah. Right. Okay. So the next one, technology. This is where we started a little bit with engineering decisions. So first we thought about going for hydrogen. We roughly estimated that the ship needs 250 kilowatts of power. Here we see a typical Ballard fuel cell, which is used on this container push convoy we saw in the introduction. And this one has 200 kilowatts, so that's quite a massive cabinet with 200 kilowatts in the beginning of its life cycle. And over the life cycle, this degrades and becomes less. So you can see it is quite big, and still we didn't store the hydrogen itself yet, and we know how complicated that is with ventilation and so on. So for a small but still powerful ship, this is not really suitable. The same for hybrid systems. We thought about going diesel electric with a battery system on it, but the batteries are so heavy and need so much space that we have a limit with our draft constraint. So this is why we kicked out the hybrid as well. And we ended up with only combustion solutions, so diesel or methanol, which are technically possible for this kind of boat. Then we went to the business filter, and we thought about what is possible to buy and what is possible to operate. You can buy methanol-driven combustion engines today, but they mostly start at around 1,000 kilowatts and then go higher and bigger. They will come in the future. It will be possible to buy a methanol engine with 250 kilowatts in a couple of years, probably, but not today. So the only real solution we could go for is actually the classical diesel solution. So we went to the design spiral with these two. We see the below deck room here. So we have the actual combustion engine, which is classic, and we have a diesel tank. So what we did is we modified the diesel tank in a way that it's capable to handle methanol in the future. So we have cofferdams, and we have the we planned a bit of space for this methanol preparation, because you can't easily pump methanol to the engine and burn it like with diesel, but you have a few preparation steps, and this can be placed in there once the technology is there. But it's not there today for this small ship, so we went for the diesel engine, of course with a very sophisticated exhaust after treatment, but still diesel was the only way to go with this tiny ship. There we go. And again, a lovely rendering. What we also clarified with the engine manufacturer, that it's possible to use HVO 100, so that's vegetable oil with e-fuel basically, which is more or less the most ecological, this way, most ecological solution if you want to burn diesel, or if you need to, rather. Right. So, what does this mean? Conclusion.
Wollen wir den Drücker. So our role as naval architects has changed quite a bit for the task that we are tackling today. So the basic understanding that we need to comply with the demands of our clients needs to be a lot broader. So the focus on different systems needs to be more in depth. We need more experts in our teams for different kind of tasks. And the job we do before we start designing is actually something like a consultant for energy. So in the building sector is in Germany it's the Energieberater. So he calculates insulations, heating systems, and so on. But this is something we as naval architects need to do a lot better, and especially our products are more energy consuming than a house with a heating system. So we need to really dig into those topics and qualify the solutions very, very early. So we do not, or our clients do not have the money to explore like every solution, and in the end we come up with, well, that didn't went that well. So there's no chance to be sorry for that in the end. So we need to qualify the right solutions on a very, very fast base. And this is actually what we are continuously developing, and we are, let's say, sharpening our tools from every task to task. We build up experience as well for different solutions, and this is something we really focus on.